As we move a little bit further into managing personal finances, another thing we will come across, which is more common, is what we call compounding interest. So compound interest grows exponentially because interest earns interest. So this gets to be a little bit more what we see. So compound usually what happens is, look, for example, monthly, during the month, you're accumulating, you're either earning money or you're spending money. And at the end of that month, they will calculate your interest. And then another month goes by, and what they'll do is they'll compound that interest again. So what they're doing is they're compounding interest on top of interest. So it could be a good thing or a bad thing, depending on whether you're like investing the money, or it could be a it could be a good thing if you're investing money. If it could be a bad thing if you're borrowing money. So when it comes to compounding, the formula gets a little bit different. So we have notice how this is the final amount. So notice how it doesn't actually calculate interest. This actually calculates the final amount. So it's going to be the initial amount, and then we have this formula, 1 plus. Notice how R is going to be the yearly rate, but we have to divide by N to determine what the interval is that we're compounding in. And then N times T represents how many times we compounded all together. So notice that time for this could go past a year, possibly even. So this is more long term as well. So like when you're borrowing for cars and stuff like this, they have some of this type of math going on. So here's a question that you will come across in your homework. This is question 5. So find the future value of each deposit if the account pays simple interest, and then part B pays interest compounded annually. So there's a simple interest and there's also interest compounded annually. So part A, if we're talking about simple interest, we know what that formula is. So because we just did that. So that's going to be, the interest is going to be the principal times the rate times the time. But also it says find the future value. So we also define future value, which they use the letter A for that, the final amount. That could be the principal plus the interest. Or there's another form that says A equals the principal times 1 plus RT. So we have two different formulas we can use. So let's approach it from this first perspective. So we know the principal is we've got $600 in the bank account. We know its rate of interest is 6%, but we have to change that into a decimal, so it's going to be 0.06. But we're keeping that money in the account for 9 years. So this is over a 9-year period. So this is kind of a little bit more longish term. So if we're just calculating interest, we would go 600 times the rate of interest, which is 0.06, times the time, which is 9 years, and that would calculate the actual interest on our deposit. So if we do the math on our calculator, we'd have 600 times then this 0.06 times this 9, and that would say we would have made $324. So if we didn't touch anything, our final amount is going to be the principal, which is $600, and then we've made an additional $324 on our investment, and therefore our final amount would be $924 would be our final amount. Now, we also could use this formula to find the final amount involving simple interest. We could say A equals P is 600. We have 1 plus 0.06 is our rate of interest. And I'm going to use a little dot here, times the time, which is 9. And then I'll go close parenthesis. So if I put that in my calculator, that should give me my final amount in one big formula. So if I do 600 and then in parentheses, I have 1 times 0.06 times 9. If I hit enter, that looks, oops, no, I should have a plus sign there. Come back in here, see if I can just type over that. Plus. So 600 times 1 plus 0.06 times 9. That looks correct. And I notice how, again, I do get that same answer just using a slightly different variation of the formula. So I do get $924 as my final thing. So part A, you're going to get a final balance of $924. Now, part B, it says do this by compounding. So compounding, our formula was going to be the final amount was going to be the principal times 1 plus R over N raised to the NT. So it looks like we need the principal, the rate of interest, the time in years, but if I'm compounding, notice how it says compounding annually. So we're compounding just one time a year. So N would be 1. So if we substitute this formula, we're going to get 600 times then 1 plus 0.06 over 1 raised to 1 times 9. So if you just substitute in, our formula would look like that. It really doesn't look much different than our other formulas. So I'm kind of curious to see where this math takes us. So 600 times then 1 plus. Notice how this is a fraction. There is this F1 key that helps me make a fraction. So if I hit the alpha button, the green button, and then hit the Y equals button, there's this little menu that pops up N over D. And I can put this 0.06 on the top and use my down arrow, put a 1 on the bottom. Now use my directional pad, come out, close parenthesis. Now I need an exponent. This is where this little up arrow comes into play. So I hit that up arrow. So that moves my little guy up here. And then if I do 1 times 9 there, I end up with, interesting, it's a slightly higher number there. So it's taking into account that we are compounding a little bit differently there. So my value is slightly different. So if we round to the nearest cent, I'm going to have $1,013, and is that going to be 68 cents or 69 cents? That 7 would say move it up to 69. So $1,013.69. That's interesting. So compounding did make that a little bit different. So we'll stop there. We'll do question 8 in a separate video.